Hi, Hari Om everyone. In this session, we are going to discuss about the electric flux. Already, I have posted one video in YouTube. Please watch that video. In that, I have explained something related to the electric flux with some examples. And I am not able to link that video in this presentation. Anyhow, I will try it. Okay, right. So electric flux is nothing but the number of lines crossing per unit area. Okay, so look at the picture here. What you have seen at the center, there is a charge plus q, and the plus q, it emits the lines of force. The lines of force are nothing but it's an imaginary line. I already told you it is originating, emitting radially outwards. What is its meaning? It is a plus charge, positive charge. And they have given two area A, B. Dimensionally both are having the same area. If I count the number of lines in this area, you can find one thing. In B, I could find 1, 2, 3, 4. So here only 4 lines are there, but in A definitely more than 4. Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So at A I have 10 lines, and at B I have 4 lines. Okay, so what is its meaning? There will be a link between area on the lines. So here, and we will know that at A the electric field will be strong, at B electric field will be less. Okay, and at the same way, A electric flux will be large and B electric flux will be small. Okay, so here you will come to know one thing. Electric flux is nothing but the number of lines crossing in a given area. Now look at the two diagrams I have given you, A, B, C. Okay, obviously at A the electric field will be less, so electric flux also be less. In B it will higher, in C it will more higher. Okay, so at C the lines of force are very close together, so obviously the electric field will be large. Okay, so this is the definition. The number of electric field lines crossing in a given area kept normal to the electric field lines is called electric flux. What is called normal? Okay, and electric flux is very scalar quantity. It's a very important point. Electric flux is a scalar quantity, and its unit will be coulomb, Newton to the power minus 1, meter to the power minus 2. Okay, and it can have the value either positive or negative. Okay, right. Now electric flux for uniform electric field. Here I have given you three different equation. The one is phi is equal to EA, and second one is phi is equal to 0, and third one is phi is equal to E cos theta into U. All these three equations will give the definition for the various occasions. The one is when the area is normal to the electric field lines. For example, when the electric field is acting in this direction, suppose if I am keeping the lines or the area, okay, normal to the lines, okay, here all the lines will be moving straight or will moving normal to the area. So in that case the flux will be EA. Okay, and the second case, when the area is kept parallel to the uniform electric field. Suppose this is the electric field. Suppose if I am placing a plate parallel to the electric field, okay, I cannot find any electric flux. So in that case the electric flux will be 0. Okay, right. And the third one, suppose if I incline some angle, this is the electric field. Now I am placing the plate, okay, now incline some angle theta. Okay, in that case the electric flux will be E cos theta times A. Okay, right. Now, so this is the example I have shown. This is the first case when he is keeping normal to that, and the second one parallel to that, and the third one keeping some angle to that. Okay, right. Now so when the electric flux in a non-uniform electric field and an arbitrary shaped area. In the previous session I told you, in the previous slide I told you what will be the electric flux when the uniform electric field and also the proper shape. Suppose when sometimes we can have a different shapes, for example spherical or a joint spherical or a square or a rectangle somewhere. Okay, in that case how I can measure? So look at the picture here. This is an indefinite shape. Indefinite shape. Here we are having three different shapes. In that case, how I can measure the electric flux? So we can have the formula. Okay. So when the suppose the electric field is not uniform and the area A is not flat. Okay. What I have to do? I have to divide the entire area into small parts. That is EA1. Okay. EA1 and A2 and A3, etc., etc., etc. Okay, and finally I have to add everything. The total flux will be integration of E dot dE. Okay, right. So now this is the different equation. You can see closed integral. Actually, closed integral is a mathematical quantity which is used to find for the closed surfaces. Okay, so the electric flux over this closed surface will be equal to E dot dE. Okay, yeah. Okay, a small request along with this presentation. Okay, you are expected or you are requested to show the another one video which I have given the link in your WhatsApp channel. Please watch that also. Thank you.